Good morning, everyone, and thank you so much for attending this talk. My name is Jose Quinteros from Scolexia. I'm a researcher, and today's talk is going to be about mitigation of spotty liver disease impact in hens using isoquinoline alkaloids. I'm going to start with a brief summary. I'm going to have a section, an introduction section, which is going to be brief, then materials and methods, then results, and final remarks at the end for you to take home. As an introduction, I can say that spotty liver disease is caused by Campylobacter hepaticus, which is a recently described bacterium. It is a gram-negative bacterium with a long bipolar flagella that can be seen in panels A and B in this electronic micrograph. It has a coccoid intermediate form that can be spotted in panel C at the bottom left, and its final form, can vary from small S shape to very long anechoic rods or bacillus. The route of transmission of Campylobacter hepaticus is fecal oral, and that's why it's more common in free-range hens, because in cage-free production systems, hens are in constant contact with the feces, with the manure, while in cage systems, there's a separation between the hens and the manure. In our experiment, we use 132 highline brown hens divided in 4 groups: negative control, positive control, low dose, and high dose of alkaloids. In the negative control, we gave a regular diet to the hens, unsupplemented, and they were not challenged with Campylobacter hepaticus. The positive control group received the same untreated diet, and they were challenged with Campylobacter hepaticus, while the high dose and low dose groups were supplemented, the low with 1.4 parts per million, and the high dose 2.8 parts per million of the alkaloids, and they were challenged with Campylobacter hepaticus. Those doses are equivalent to 100 to 200 milligrams of the final product per kilogram of feed. And the challenge dose, as can be seen here, was 10 to the 9 to 10 to the 10 Campylobacter hepaticus cells of the strain HV10. Each one of the groups previously mentioned was subdivided in 2 groups. Short groups that were euthanized 7 days after challenge, that were used to study, count, and score the hepatic lesions, while the long groups were kept until 29 days after challenge, and they were evaluated in terms of production, so production parameters. So it was evaluated the feed consumption, at feed conversion efficiency, the weight of the hens, the weight of the eggs, and the egg production. Results. We saw that the number of positives to spotty liver disease in the negative control group was equal to 0, which was obviously expected, and the other groups had higher numbers of positive, significantly higher, but they were not different between each other. So positive control, low and high dose were not different in terms of number of positives. However, in terms of hepatic lesions, we saw a decrease in the number of lesions, especially in the group with a high dose of alkaloids. And that difference was significant compared with the positive control group. On the other hand, in terms of scores, even though the median score was lower in the high dose alkaloid group compared with the positive control, it was not significant. Anyhow, was close to significancy with a p-value of 0.11, when the cutoff value was 0.05. In terms of feed consumption, we compared the feed consumption in grams per hen per day before exposure and at the moment of the euthanasia. So in the short groups, there was not a difference between the consumption before and at the moment of the euthanasia. But in the long groups, 29 days after exposure, there was a difference, an increase in feed consumption only in the high dose alkaloid group. In terms of the weight of the hens, we compared the initial weight and the final weight. And obviously there was an increase in weight, as can be seen in panel A, in all the groups. However, the increase in the positive control was less significant when it's compared with the negative control and the high dose supplemented group. In panel B, we can see that the initial weights were compared with, between the groups, and there was not a difference in the weight at the beginning. But at the end, the high dose alkaloid group, supplemented group, the weights of the hens were significantly higher compared with both controls. In terms of feed conversion, we know that the lower the value of feed conversion rate, is the efficiency is better. And we can see here that the efficiency in the negative control group was improving over time. That didn't happen with the positive control group, when we see a decrease in efficiency 6 days after exposure. Okay, that decrease in efficiency was prevented in both groups supplemented with alkaloids. In terms of the weight of the eggs, we could see that the weight of the eggs, the average, was improving between sampling days in the negative control group. However, in the positive control group, we saw something that hadn't been described for Campylobacter hepaticus before. There was a decrease in the weight of the eggs 6 days after exposure to Campylobacter hepaticus, around a week. And that didn't happen in the high dose alkaloid supplemented hens, where there was a steady increase in the weight of the eggs. In terms of egg production, we could what we did is that we measured the egg production before the challenge, and then we took that number and we extrapolated, and that was the expected number for these hens to be produced after the challenge. What we saw is that in the negative control group was an increase in the number of eggs in that post period. However, that increase was not as dramatic in the positive control group, even though there was an increase, but was significantly lower compared with the negative control group. However, in the high dose alkaloid group, supplemented group, we can see that it's equal to the increase that we had in the negative control group, and it was significantly higher compared with the positive control group. So, as final remarks, we can say that first, spotty liver disease was not fully prevented by this alkaloid in the diet. So the number of positives to the disease was the same between supplemented and unsupplemented birds. However, there was a clear reduction in the severity of the disease, measured as the number of spot or lesions in the liver, the surface of the liver. Also, there was a better increase in feed consumption and weight of the hens, and an improved feed conversion efficiency. It seems that could be related with the anti-inflammatory properties of these alkaloids in the mucosa of the gut of the chickens. Also, these alkaloids seem to prevent that drop in the weight of the eggs 1 week after exposure to the disease, which could be also a very positive outcome of the study. And the total egg production of the group supplemented with alkaloids was better compared, especially the high dose, were better compared to the positive control group. So thanks so much for your attention. I want to acknowledge the Australian government for the financial support through the Innovation Connection Grant. And I also want to acknowledge the collaboration with Phytobiotics and with RMIT University. Thank you so much for your attention, and I'll be waiting for your questions at the end of this session.